Hi, my name is AaronJamesDelosReyes, and I will be doing my course project in HP load testing, and I've chosen the topic using runtime settings in HP load testing. So let us know, what is HP load testing? HP Load Runner is a performance testing tool used to simulate virtual users accessing an application to test how it behaves under load. It helps assess the performance and scalability of systems before they go live. So here are the components of HP Load Runner. We have system behavior analysis, which observes application performance under load. Second, scalability assessment, which evaluates system capacity to handle growth. And lastly, performance testing, which simulates user load to test application behavior. So let us know, what is the purpose of load testing. First, it identifies performance bottlenecks, ensure the application can handle expected user loads, and prevent system failures under stress. Next, let us understand runtime settings. So what are runtime settings? Runtime settings are configurations within HP Load Runner that allow you to customize the behavior of your load test during execution. They define how virtual users interact with the application under test, or AUT, and determine parameters like pacing, think time, and error handling. So why are runtime settings important? It is important because it achieves testing excellence. So to achieve testing excellence, here are the key points. Uh, Flexibility, which enables diverse testing scenarios without script alterations. Performance, which maximizes resource efficiency. And precision, just virtual users' behavior for realistic usage pattern. Key runtime settings in Load Runner. Here are the key runtime settings in Load Runner. First, we have virtual user population, controls number of virtual users in a scenario, can simulate gradual ramp ups, or sudden spikes in load. Next, pacing, which defines the delay between iterations of a virtual user's actions. It helps to simulate more realistic user behavior with delays between requests. Next, think time. It represents the delay a user might experience between actions, for example, browsing or making decisions, and it mimics real-world behavior, avoiding unrealistic rapid-fire requests. Lastly, transaction duration specifies the duration of a transaction, for example, how long a virtual user takes to complete a specific task. Important for measuring the performance and response time of critical functions. So let us know advanced runtime settings. So here are the key points of advanced runtime settings. First, we have error handling that manages how errors are processed during testing for flexibility. Ramp up time that controls the gradual increase of virtual users over time. And network emulation that simulates different network conditions to test application performance. And lastly, global variables that allows runtime changes to parameters for dynamic testing. Next, using runtime settings to simulate real-world scenarios. We have load patterns that customize settings to simulate different user load patterns. For example, constant load, spike, or ramp up, and realistic user behavior uses spacing and think time to replicate actual user behavior rather than mechanical immediate requests, and error simulation that tests the system's resilience by introducing errors like network latency, timeouts, or server unavailability. So here are the best practices for using runtime settings. First, we need to plan test scenario. Define the objectives of your load test before configuring settings. Next, balance load distribution. should consider using a mix of different load patterns to evaluate performance. And third, monitor and adjust. Make sure to keep an eye on system performance and adjust settings as necessary. And lastly, test at scale. Ensure load tests can handle realistic user loads by configuring virtual users. So here are the steps for best practices for using runtime settings. Next, I've also created an example of testing an e-commerce website. Here are here is the scenario: load testing for an e-commerce website during a Black Friday sale. So the runtime settings used ramp up to simulate user traffic, slowly increasing as the day progresses. Pacing and think time used to simulate realistic shopping behaviors, and error handling settings for intermittent server issues during peak load. So what is the outcome? Here is the outcome. The test showed how the website handled increased traffic and identified several performance bottlenecks, including slow response times on product pages and issues with the payment gateway under heavy load. So load testing is very useful for a scenario just like this one. So in conclusion, runtime settings enhances load testing, and as a result, runtime settings are essential for fine-tuning the behavior of virtual users and testing real-world conditions. Customizing these settings enables better simulation of actual user interactions and system performance. And lastly, proper use of runtime settings helps improve the accuracy and effectiveness of load testing. I hope my presentation was clear. Thank you.